Assalamualaikum and hello everyone. My name is Muhammad Shahir bin Masno, number matrix CE230146, and I'm from group number 3. So basically the first question that I will be presenting to you is question 1. So question 1 consists of 3 parts here. We need to plot a graph of the current versus time. For part B, we need to find the voltage across as a function of time, plot the graph of the voltage versus time, and calculate the voltage value. Finally, for part C, we need to find the power, PT, plot the graph of the power versus time, and determine the power when t equal to 0.4 seconds. The information given is, if the current is a 3 microhenry inductor, is it I times t equal to E negative 4t cos 5ta. So, the first step that we need to do is manual calculation of actual value. So, first of all, we will write down all the equation given earlier and find the value of t. So, we will get the answer of 5 after solving it, and we will proceed to the next step. After we get the value of t, we need to differentiate u and v. So, u is exponent or E negative 4t, and v is cos 5t. So then we will differentiate u, and then we will get negative 4e negative 4t, and differentiate v, we will get negative 5 sin 5t. Then we will use product rule to get the true equation of this question. Product rule stated that u v prime plus v u prime, and we plug in the value that we get earlier. So u is E negative 4t, v prime is negative 5 sin 5t, plus v cos 5t, and u prime 5 sin 5t. We take both of these elements and rearrange it in the simple form. Then we will use the formula of v equal to L di over dt. So this formula is where the L is inductance, I is Henry that we get from the question, that is 3 microhenry, and di dt represent the value that we got earlier. So we will plug in all the value in the equation and replace t with the value that we get earlier, that is 5 milliseconds. So we can solve the equation and get the final answer of negative 1.21 times 10 the power of negative 5 volt. For question C, we need to find the power and use the formula P, and use the formula P equal to V times I, and use the V formula earlier and take the I from the question A that we solved earlier. So then we will plug in the t value of 4 seconds based on question C. So earlier we do 5 seconds, now we do 4 seconds for the t. Then we can solve the equation and get the power value that is 1.467 times the power of negative 7 watts. For the next part, we will be using MATLAB to plot the graph of the current versus time. So we need to define the time value to the suitable range of the graph created and set it to the adjust time range as needed. So next, we need to define the current function that is given in the equation before I times t is equal to E negative 4t cos 5t. Then, we give the command to calculate the current value based on t. After that, we need to specify the graph to be plotted by defining plot as t and current value with the line width of 2. We label the x with the time in second and y with the current with a as unit. We enter the title and of the graph that is current 3 microhenry inductor versus time, and set the grid to on to get the better result. And now we will command the plot and limit the axis by using tie and the legend by current. So the result is produced right here. And then for question B, we will define the time value as 5 milliseconds and do the same thing as before for current function. So for the derivative of current to get to the voltage, we need to use dt t2 minus t1 and write down the equation to be declared. Then we will do the same thing as before, but change it to the voltage value, and we will define the plot in the graph with t and voltage with the line width of 2 with the value of X label and Y label as voltage, and then we will do the title, and finally we will insert the command to determine the voltage value at t minus 5 seconds. So we will declare it, and the graph will be shown in here. Finally, for question C, so the line value of t is replaced by 0.4 second, and we will do the same for current function and voltage function. Then we can define the power function formula of the addition of voltage times current function. So we declare the power value and power function of t, then we will do the same as before.
Next, in question 2 consists of three parts. For part A, plot a graph of the current versus time. For part B, find the voltage across as a function of time, plot a graph of the voltage versus time, and calculate the voltage value after t equals to 0.4 millisecond. For part C, find the energy, plot a graph of the energy versus time, and determine the energy stored at t equals to 5 seconds. From the information given, if the current in 9 millifarad capacitance is IT equals to 4t power of 3 hyperbolic sine t milliampere. To plot a graph of current in 9 millifarad capacitor versus time, we using MATLAB software to solve this problem. The first step is define the time value V is from 0 second to 5 seconds. The second step is define the current function IT equals to 4t power of 3 times hyperbolic sine t. The third step is calculate the current function. The last one is plot the graph. We plot the t as a x label and plot the current as a y label, then the graph will show. In linear calculation, we need to find the voltage value after t equals to 0.4 milliseconds. As we know, the formula of voltage is equal to 1 over C and differentiation current. The first step is we need to integrate the current, which is IT equals to 4t power of 3 times hyperbolic sine t. The method we are used is by using the integration by part. In this question, we need to integration by part for 3 times to get the answer. Next, the formula of our energy is 1 over 2 CV squared. We substitute the C equals to 9 millifarad and also substitute the voltage value when we get before to get the answer. Find the voltage across as a function of time, plot a graph of the voltage versus time, and calculate the voltage value after t equals to 0.4 millisecond. The first step is define the time value from 0 second to 0.4 millisecond. The second step is define the current function, which is it equals to 4t power of 3 times hyperbolic sine t. The third step is define the capacitance, which is C equals to 9 millifarad. Then we integrate the current to get the voltage value, and also plot the T as an X label and plot the voltage value as a Y label. Then the graph will show. And also we need to determine the voltage value and T equals to 0.4 milliseconds. In part C, we need to find the energy, plot a graph of the energy versus time, and also determine the energy stored at t equals to 5 seconds. The first step is define the time value from 0 second to 5 seconds. The second step is define the current function, which is it equals to 4t powers of 3 times hyperbolic sine t. The third step is define the capacitance, which is C equals to 9 millifarad. For the next step, we need to integrate the current to get the energy function. Then we plot the T as a S label and plot the energy as a Y label, and the graph was shown. The last step is we need to determine the energy stored at T equals to 5 seconds.